Welcome to the Science Lab.
Hi everyone, welcome to this Occupational Safety and Health or OSH training video for Applied Science Laboratories at UiTM Shah Alam. This video is developed as an open educational resource to support students and laboratory users in understanding laboratory safety, common hazards and safe working practices in lab.
But first, let me introduce to you my lab team. The first one is Nur Shahida. The ID student is 2025-430-654. Next, Nur Anisa. The ID student is 2025-226-016. The last one is Nur Maisara. The ID student is 2025-481-498.
What is OSH? Occupational Safety and Health, or OSH, focuses on protecting people from injuries, illnesses, and accidents in the workplace. In laboratory environments, OSH is especially important because students and staff regularly handle chemicals, biological materials, and special equipment that can be hazardous if not managed properly. Why OSH matters? In Malaysia, laboratory safety is governed under the Occupational Safety and Health Act 1994 and the Occupational Safety and Health Amendment Act 2022. This law requires employers and institutions to provide a safe working environment, proper training, and suitable personal protective equipment. At the same time, students and lab users are responsible for following safety procedures and using equipment correctly. This shows that safety in laboratory is a shared responsibility. OSH in everyday lab life. In everyday laboratory activities, OSH can be seen through simple but important practices. These include wearing complete personal protective equipment, maintaining clean and organized work areas, following standard operating procedures, and using laboratory equipment responsibly. By applying OSH principles consistently, risk in the laboratory can be significantly reduced.
This image shows an example of poor laboratory housekeeping. We can see chemical containers left on the bench, used to place on tissue paper, and chemical residues on the work surface. This situation can lead to several hazards such as chemical spills, skin contact, contamination, or even fire risk. Poor housekeeping also increases the chance of accidents, especially in shared laboratory spaces. Good OSH practices requires all lab users to clean their work areas after experiments, store chemicals properly, and keep benches organized. A clean lab is one of the simplest ways to reduce risk. This visual shows an example of improper personal protective equipment or PPE usage in the laboratory. In this situation, the lab user is not wearing complete PPE such as safety goggles, gloves, or a lab coat. This increases the risk of chemical splashes to the eyes, skin exposure, and contamination of personal clothing. PPE is the last line of defense in the hierarchy of control. Even when engineering and administrative controls are in place, PPE must still be worn correctly at all times. Wearing full PPE may seem simple, but it plays a very important role in preventing injuries and exposure in laboratory work.
This image shows laboratory equipment commonly used in applied science lab, such as a rotary evaporator and a heating bath. While this equipment is essential for experiments, it also presents physical hazard. This includes hot surface, glassware breakage, electrical stress, and pressurized system. If the equipment is not handled properly, it can cause burns, cut, or equipment failure. This highlights the importance of proper training before using laboratory equipment. Users should always follow standard operating procedures and ensure equipment is switched off and clean after use. To control laboratory hazard, OSH uses the hierarchy of control. The first step is elimination or substitution, where hazardous material are removed or replaced if possible. Next are engineering control, such as fume hoods, safety cabinets, and ventilation system. Administrative control include lab rules, safety sign, and training session. Finally, PPE like lab coats, gloves, and goggles provide the last layer of protection. Using all these controls together help reduce risk and keep laboratory users safe.
The first hazard we see is the handling of an explosive liquid. In a real lab, chemicals are categorized by their DHS level. Mixing or exposing flammable liquids to an open flame without a fume hood is a critical safety violation. This represents a chemical hazard where rapid oxidation leads to an explosion.
Notice the scientist's gear. While he wears glasses, he lacks a proper lab coat, gloves, or a face shield. When the explosion occurs, his skin and hair are directly exposed to the blast. This highlights the importance of personal protective equipment (PPE) as the last line of defense against thermal and chemical burns.
Lastly, look at the workspace. The lab is cluttered and he is working far too close to the chemicals. The physical hazard here is the lack of a controlled environment such as a blast sheet or a safety cabinet, which result in the shattered glass and soot we see in the aftermath.
Checking for safety first. If you hear the telltale crash of glass, take a deep breath and stop. Before you grab a single paper towel, ask yourself, do I know exactly what was in the bottle? Safety is our top priority, so you should only handle the cleanup if you are being trained and know the chemical isn't a major hazard. If you are ever unsure, just grab a safety data sheet (SDS) to check the rules, or call the EHS team. There's no shame in asking for help. It's much better to be safe than sorry. Setting the perimeter and clearing debris. Once you are confirmed it's safe to handle, go ahead and grab your spill kit. Think of this next part like building a little dam. Take your absorbent barriers and place them all the way around the spill to keep it from wandering off on the cabinets or equipment. Now we need to get the glass off of the way, but never use your hands. Use the pair of tongs to pick up the shards and pop them into the glass disposal box. If the bottle had a waste tag, peel that off and save it. It's going to be very important for our labeling later on.
Now, we're ready for the floor dry. The trick here is to work from the outside. This keeps the liquid pushed toward the center so it doesn't spread. Pour the floor dry over the spill until it's completely covered and then just hang out for a few minutes. You want to give that material enough time to really soak up every last drop. Once it looks dry, give it a little stir to make sure there are no hidden wet spots, and then you can easily sweep it all up into a neat pile. Almost done! Sweep that used floor dry into a plastic bag and seal it up tight. Remember that tag with safe? Tape it right onto the bag and write spill cleanup material in big letters so everyone knows what's inside. After that, just give your lab supervisor a quick heads up that the spill happened. Finally, do your future self a favor and restock that spill kit right away. You'll feel much better knowing everything is ready to go if another accident happens.
To conclude, occupational safety and health plays a crucial role in ensuring safety in applied science laboratories. Unsafe practices such as poor housekeeping, improper use of personal protective equipment, and incorrect handling of laboratory equipment can lead to accidents and injuries. However, these risks can be minimized by following OSH principle and maintaining good laboratory practices.
That is all for
This
now.
open
Thank you for
educational
listening.
resource and
Bye.
can be used for laboratory induction session, safety briefings, and refresher training.